So like we've listened to a lot of talks about shiny new features, and I'm going to talk about old stuff like ESM was standardized. ECMAScript Modules were standardized 7 or 8 years ago, so this is not really bleeding edge, but like still something fun that we've done in the past few years. And as like she already mentioned, I maintain Babel. We maintain Babel for now 6 years, and I started working at Igalia like 1 year ago, and we basically like work on open source projects such as browsers and compilers and standards and so on. So we're all tired. I was a bit sleepy before this talk. It's late now. So let's start a bedtime tale. And once upon a time, there was a little JavaScript library written using the shiny new import export syntax and published in npm compiled to CommonJS. And it was just living its life, helping millions of developers shipping their JavaScript code. Until one day, suddenly, an issue arrived in its life. And nothing was ever the same anymore. Not only one, other. And our adventure begins here. Chapter 1, Introduction. So all my talks about Babel always start with this slide. What is Babel? And usually the answer is Babel is a JavaScript compiler, except that it doesn't matter at all for this talk. Babel is a built-time dev tool, and it's a configurable dev tool. So you can run Babel, and Babel loads some configuration file that can affect how it compiles your code. So for example, you can define like some target browsers and a bunch of stuff. And Babel is a pluggable dev tool. So in your config, you can define some plugins, and Babel, while compiling your code, will dynamically load these plugins to apply some transformations and that are needed for transforming your syntax. And Babel is an embeddable dev tool. Can be embedded and can be integrated in many different other build tools, such as Webpack or Rollup, and even just linters or formatters, and almost every single bundler supports Babel at this point. And all these answers to what is Babel deeply affect how what was easy and what was difficult for us when migrating from CommonJS to ECMAScript Modules. ESM, ECMAScript Modules present some challenges, or at least the migration from CommonJS to ESM presents some challenges. First of all, ESM cannot be synchronously imported from CommonJS in Node. So you cannot use the import statements because they can only be used inside other ESM files. You cannot require an ECMAScript module. The only way you can load it is through dynamic import, except that it returns a promise. So it's not really equivalent to require. And similarly, it cannot be synchronously imported dynamically, not even in another ESM file. And you're always forced to use dynamic import, and that always introduces a promise and asynchronicity in your program. Then ESM compiled to CommonJS works differently from native ESM. It has a different interface. Maybe sometimes it's happened to you that you tried to import a JavaScript library that was original, written ESM and compiled to CommonJS. You tried to run this directly as ESM in Node without compiling your app code, and you've seen that it doesn't really work. For example, if you try to import the default value, you sometimes get this object with an ESModule2 property and then a default property on the object that you expected to not be there because you already tried to import the default. And lastly, ESM doesn't really integrate with different tools that virtualize how require works in Node and how CommonJS files are loaded. And they're all doing a little bit of magic, to provide mocking or on-the-fly translations and other things that you shouldn't really do unless you really know what you're doing. So the other thing that affected how we migrated our code to ESM is that we can think about code that interacts with Babel as internal and external. Internally, we have our own source code, which is written by 3 to 10 people maybe, and it's used by all Babel users. And we have Babel tests that are written by 3 to 10 people and only used by 3 to 10 people, and some CI bots. Then we have Babel configuration files that are written by almost every single Babel user, unless your bundler or tool that you use to run Babel abstracts it away from you. And we have plugins that are written by like maybe thousands of developers. So it's much less than the number of developers that write Babel configuration files, but it's much more than the number of developers that works on the Babel source code. And the highest priority for us was to make Babel work with ESM, at least when it comes to external files. So like configuration files and plugins. In November 2019, Node.js unflagged their ESM implementation. And this is the 21st of November 2019. And just 2 days after, we got our first issue asking, hey, please, can you let me use ESM in my config files? This is not really migrating our internal code. This was about letting Java, like Babel users, do whatever they wanted with their own files. And as we saw before, it's not really possible to synchronously load files if they're written in ESM. So in order to support that, we needed to make Babel support asynchronous config loading, or like asynchronous resolution. And that was the first challenge that we faced. It was complex to do so because async await is kind of like a virus. Like this code is just like a very long number of functions, don't need to read all of them. Just notice that the one on the top left is the transform function, which is like the entry point of using Babel. You call like Babel.transform, pass in some code that you want to compile. And then on the bottom right, all the functions that are needed to load the config. On the bottom right, there is where you actually require your config file. And we use the require, which is synchronous, and we're expecting your config file to be a CommonJS file. And how do we add support for ESM config files? Well, we replaced that require with an await of a dynamic import, except that await can only be used in asynchronous functions. So this load code default function suddenly needed to become async. And then how do we call this load code default function in read config code? We need an await, and the virus spreads, and suddenly all your code base need to be asynchronous. And like this might be fine, except that we really wanted to try preserving our synchronous API for backward compatibility, because like some people don't care about using ESM in their configs, so they don't really need to use Babel asynchronously, and they may be already using Babel in contexts where like they're already calling it synchronously. Why should you break their code if they don't care about what's unlocked by the asynchronous transforms? And one way to do so was to maintain two parallel separate implementations like Babel's transforms and config loading, a fully synchronous one and a fully asynchronous one, with ESM only supported in the asynchronous version. The problem with this is that like you need to maintain two parallel implementations and make sure that when you find a bug in one, you need to check if the bug also applies to the other, and you need to make sure that it remains sync. So can we have a single implementation capable of running both synchronously and asynchronously? We initially thought about maybe callbacks, like you pass a callback and then you can either call it synchronously or asynchronously, but like we all fell in love with async await because it makes it much easier to run async code compared to callbacks. Like callbacks don't really work with loops and like with conditionals. So could we do something better? And yes, one of the Babel maintainers came up with this library called gensync, which abstracts the whatever is named for synchronous versus asynchronous. And like here, it took me a while to find the word. Like I went for a tangent and asked help to like a bunch of people until they suggested execution model. It was too large to fit there. Like I just squashed it a bit and it fit. So that's why the next slides look slightly off. And this is gensync, like the description say, like it allows you to hide whether the underlying request happens synchronously or asynchronously. And this is different from like most of the stuff, like in Node.js, where you have the asynchronous version of most API. So if, for example, we had this read JSON async function that asynchronously reads a file and then parses its contents, with gensync, we could use like a generator function that uses yield star instead of await. It's almost just a like find and replace. And read JSON can then be called either synchronous or asynchronously. And we just need to make sure to provide like the correct entry points. So read file cannot just be an asynchronous function. It needs to be a gensync function that can run either synchronously or asynchronously. So, and you can define all the utilities you want that like branch depending on like whether it's sync or async. And so we use this for Babel for our config loading process. We literally just replaced every async function with a generator. And like this is probably the best use case I've ever had for generators. I don't really use them much. Does someone use them in their day-to-day job? Yeah, that was like the first time I was using them for real. And like we only need to wrap the entry point with gensync and then the exit point as we saw with gensync again. Like in this case, how was load code default then implemented? Well, we can just like export all the versions for our function. How was that implemented? Instead of having the asynchronous version of that, like one supports only CommonJS, the other one supports both, like we could have our generator that like loads the CommonJS file. Then if we're in a synchronous context, we can, like we are doing something async, so we can use promises. Otherwise, it just throws an error that it's not supported because we're trying to load ESM synchronously. And so in January, like end of 2019, beginning of 2020, we actually like finished preparing Babel core, which is like the config loading package for asynchronicity, thanks to this gensync package. And this was maybe 1 month after, 2 months after Node.js unflagged their ESM implementation. And like you can see, a pull request is literally just like adding some generators here and there. And so short later, we supported MJS config files, and a year later, MJS or like ESM plugins and presets. Like this was lower priority. Like I don't really know why it took us 1 year, but like what was important, the config files were like supported ESM as soon as possible. So what do you do after making your library asynchronous? Well, you make it synchronous again. Like sometimes you can force your users or consumers to use their asynchronous API, and sometimes you can. Like it was like I'm saying force here, but like it was almost like a collaboration process. Babel has a very small number of direct API consumers. Like as I mentioned, Babel is integrating Webpack rollup parcel. You usually don't directly call the Babel like the Babel JavaScript API. So like there is a fix, like a small number of places we need to update, and we ensure that all the integrations supported calling Babel asynchronously. Except that for some of them, this was not possible. One was Babel ESLint parser, which is our ESLint integration to parse like new syntax based on your config. ESLint only supports, or at least only supported asynchronous synchronous parsers. And the other one was Babel register, which hooks into the Node.js require function to compile files like on the fly as you require them. And like requires synchronous, so you cannot have asynchronous tasks there. And how did we solve this problem? Using Worker from Worker and Atomics, like the low-level built-ins for having like work multiple threads and like synchronizing worker jobs within multiple threads. So we moved a ESLint parsing and Babel register implementation into a Worker. Then like it was like we considered a breaking change, not because it was really breaking, it just was like potentially unsafe since it was like completely rewriting how these packages were written. So they're only exposed as experimental now, even it's been like 2 years. And how does this work? So in the main thread, we have like our synchronous function that really has an asynchronous implementation, but that should only be an implementation data. So then we have our worker thread. And they need some way to communicate and to synchronize with each other. So the main thread creates a shared array buffer, which is raw memory you can share and like access at the same time between different threads. And it needs to create a message channel, which is a Node.js API for like synchronous communication, like not only like raw memory, but actually like structured like objects and like other JavaScript things, synchronous communication between multiple threads. The main thread sends the payload, with all the information about the task to perform, and this signal and this communication port to the worker thread. And then using atomics.wait, it just leaps. This wait signal 00 means sleep if the 0th element of our shared array buffer is 0. And just sleeps and does nothing. It's not an asynchronous pause. It's literally like putting the thread to sleep. And in the meantime, the worker thread can perform its asynchronous tasks. Like I forgot a sync there, but you can see a wait. And when it's done, it sends the result using the port, like the message channel port to the main thread. Then it updates the signal, replacing like the 0 value with 1, and it notifies the main thread that something has changed. So when atomics.wait in the main thread gets notified, it like wakes up and it synchronously reads the message that the worker already like stored in this message channel, and it can synchronously return the result. And I've gone very quickly through this because I had more slides, but I will need more time. So if you like need this for some reason and you want to read more in details, there is this very good article from Giuseppe Gurgone, because like we came up with this implementation together, and you can like Google for Giuseppe synchronizing sync function. I'm sure you can find the article quite easily. And then chapter 4. So we now supported loading config files as ESM, plugins as ESM, and we managed to keep backward compatibility in places where it was not really possible to run Babel asynchronously. But our main code was still all written in CommonJS. Our users could use ESM. Like, we didn't want to stop there. We wanted to migrate to a new thing. And since like a full migration is potentially like can introduce many bugs, we didn't really want to do that with the code we publish in NPM. So we started by only migrating our tests, which are like written by a bunch of people and only run by a bunch of people. And that was like seemed safer, except that it was very, very hard to do so because the ecosystem wasn't really ready. And it's way better now, but like there are still many rough edges. We found two main problems. One was, as I mentioned before, that ESM compared to CommonJS behaved differently from native ESM, and like that means that we couldn't just stop compiling from ESM to CommonJS. We had to do something more. And the second problem was the test runner we used, Jest didn't or still doesn't properly support running ESM. Okay, let's see how we solve the first problem, but first with some background. If you've ever looked at code compile, ESM compiled by Babel, TypeScript, or like any other JavaScript compiler, you might have not noticed this __ ESModule flag. What is it? Why do we need it? So assume you have these two files, these two ESM files you can see on the left. One that exports a bunch of values or functions, and one that imports the function, like the default export, and then it just calls the function. How do we compile this to CommonJS? What all the compilers do is to expose all the exported values as property of the CommonJS exports object. So you can see on the right that we have in the first file exports.py and exports.default. And when compiling an import, we require the compiled CommonJS file and we just read the properties. So in this case, we call math.default because we want to call the default export. However, what happens if our math library was not ESM compiled to CommonJS, but was manually written CommonJS? Usually, you would export a value, just assign it to module.exports. Like when you manually write CommonJS, you don't really write exports.default equals to something. So the compiled version of our bottom file shouldn't access the default property of this _math object. You should just call it. It's already our function. And this is different from how it works for when we're importing an ESM library compiled to CommonJS. So how do we fix this? Well, what Babel does was that it just takes your CommonJS, manually written CommonJS library and puts in an object with a default property, so that then accessing the default property from _math just works. Except that it needs to check if the library importing was ESM compiled to CommonJS, or if it's just manually written CommonJS. And we have this interop required default helper to do so. And how can we do this? Is ESM compiled CommonJS check? That's where the __ ESModule property helps us. Every compiler that compiles ESM to CommonJS injects this export.__ ESModule flag, so that then our interop required default function can check this flag and knows how to behave. And this convention is very, very old. It was first introduced in 2014 in Trusser. 2014 was even before that ESM was standardized. That was shipped in ES6 in mid-2015. So this was more than 1 year before. And it was first just for AMD, and then it was also ported to CommonJS. And this convention is supported by every JavaScript tool, as I mentioned, like Babel, Trustworthy, CSWC, and like all the various bundlers. And except that it's not supported by Node.js. So when you have, like we have our math.commonJS module on the left, which was written as ESM and then compiled by like Babel or something else. It has this underscore module property. And if in Node.js we try to import it, we see this object like with the ES module flag, with pi, with default, instead of just having the default export. So this shouldn't be a problem in theory, because you're either compiling ESM to CommonJS or you're not. You shouldn't have this situation where some files are ESM compiled to CommonJS and some files are just ESM. Except that that's not true in practice. Like almost always, you would convert some files to ESM and some of it just like run as native ESM. This is because we all depend on libraries from NPM, and many libraries from NPM are ES modules compiled to CommonJS. So we can stop compiling our own files. We cannot stop compiling those files because we don't control them. And for us, for Babel, this was also because we only wanted to stop compiling the tests and not the main code. So the problem for us was even like bigger. Because like converting some files is a problem, because if we don't convert anything, everything works. If we convert everything, everything works. And like we need some files, like this is still converting, everything works. And like you convert one file, not the other, it doesn't work. Because as we saw before, circ is like now an object with the ES module and default properties and not the function itself. So how do we fix this? Well, one way would be to manually write .default in your native ESM modules. Except that then, if like for reasons, for example, because you also want your library to be compatible, or like your application to be compatible with older version of Node.js, like Node 6, that is many years old and be able to support for some crazy reason, like then it would stop working as soon as you start transpiling your ESM files for some targets, because now you have this double default access in transpiled version. So the first one works and the second one wouldn't work. So we had to figure out a way to fix this. And like Node tool yet had really a solution, because Node.js implementation was quite new. And like it was only Node like not behaving as everyone else was behaving, except that like Node is the one now sets the standard because it's like the different time. Okay, so what we came up with was like a new option for Babel called import interrupt node that basically tells Babel, ignore this ES module flag. I know it's what everyone does, just ignore it, pretend it doesn't exist, and behave the same as Node. And we then start implementing these other tools, such as Rollup, except with a different name, because we also use Rollup, and other bundlers, other compilers started shipping something similar, because it was like the goal was not only anymore being compatible across different tools, we also had to be compatible with Node. So we solved this first problem, and now our code, our manually written ESM, could either run as ESM, or we could compile that to CommonJS. It would still work in both cases. And then here comes problem 2. That Jest, how many of you use Jest? Okay, yes. Jest is like one of the most popular, as we can see, test runners. And they received the first feature request to support native ES modules in 2017. That was 2 years before Node.js unflagged their ESM implementation. Like it was already implemented just behind the flag with like many big warnings about it being experimental. And the Jest team actually started working on this in January 2020, so just like 2 months after Node.js unflagged it. And they're still working on it. Like you can see that small icon with number of tasks. There are like 15 out of 21. It's not working pretty well, except that we needed this to work 2 years ago, and it's still not done yet. And like it's not their fault. The problem Jest has is that Jest runs every test in a virtualized context using Node.js VM module. It doesn't run your tests like directly on bare Node.js. It does so to isolate every test file so that you have like some tests with like some very bad bugs that will make all other tests crash. They're isolated, so only one file is affected by those bugs and not all the other files. or like if you are not very good at like isolating state, Jest does that for you. And also it abstracts away the linking process between modules to intercept all the required calls, all the imports, so that it can allow mocking dependencies. Like with Jest, you can say, during testing, replace this module with this other module. Or it can transpile modules on the fly. Like for example, Jest runs Babel internally for some things on your tests. And the problem is that the VM Node.js built-in module doesn't really work yet with ESM. And like we found many bugs trying to run ESM natively in Jest. Like for example, some crashes, which are not like just errors, like errors thrown by Jest. They're actually Node was crashing from their like C++ code. And we reported this to Jest, then this was reported to Node when we discovered other seg faults related to this. Like this was V8 crashing with this like C++ stack trace that I have no idea about how to read. And Node is actually like working on stabilizing ESM support in VM modules, except that you can see there are still different missing checkbox. And like someone also reported these issues to V8 and they're still not fixed. So before being able to use native ES module in Jest, it will take like a long time. The road ahead still. Many people should help them with this. And so how did we work around this problem? Well, Jest is like usually defined as a test runner, but Jest is much more. Like I use Jest not because like it's test runner. I use Jest because I like the CLI with all like the green and red colors. I use Jest because I like their expect API for assertions. Like I don't really care about how Jest runs tests. What I care about Jest is it's like the X. So we replaced the test runner used by Jest. Jest supports like something similar to Babel plugins. You can write your own runner and still like integrate it with all the Jest ecosystem. And we called it Jest Light Runner because it was just lighter than Jest Runner. What it does is that it runs your code directly in Node.js without virtualizing or without using the VM module, without virtualizing or your like module loading. It doesn't isolate your tests. We decided it was okay for us because like our tests are usually stateless, so it was not a problem. And by the way, if you want to run Jest with ESM and you're having problems, I strongly recommend using this. It's now used also by Prettier and by a bunch of other projects, and like it's working well. And so we started using this in Babel, and it was blazing fast. Like the time to run our test reduced from 5 minutes to 2 minutes because like we're doing a lot of less work. We didn't need to like re-implement all the things implemented in Node.js. And so like not only we managed to run ESM with Jest, by just using Node implementation, we also saved like a lot of time, a lot of like energy, and like we helped the environment because less electricity. And that was satisfying. So we solved both our problems, and at this point, our tests were running as native ESM, and our tests were also being able to be compiled to CommonJS to still work. We're running them in very old Node.js versions. And then chapter 5, getting ready for an ESM release. So now external code was all ESM compatible. Our tests were ESM compatible and were running as ESM. The only missing piece was our main code that we published to NPM, our release code. There are different approaches that library maintainers are taking to migrate their libraries to ESM. And the most popular one is to release them as dual packages. A while ago, I think it's been a few years now, Node.js released support for this exports field in their package.json, where you can basically say, hey Node, if my library is being imported using require, then use this CommonJS implementation. If it's being imported using import, then use this other implementation. And converting a package, like a CommonJS package to the dual package, while still preserving compatibility with all the Node.js versions and with all the tools that you could use, your library could be used with, is incredibly complex. We try to do that for one module that we have, Babel Runtime. Babel Runtime is a bit different from all the rest of Babel because Babel is a build tool, so you use it at development time, and Babel Runtime contains all the runtime helpers that are used at runtime in your application. So we wanted to convert this to ESM first so that people could start using it with native ES modules in the browser. And we try to do that using conditional exports without breaking changes. And we had to analyze a lot of different cases, like what happens if I import a node, if I use require a node, if I use it with a bundler. Like we had to check what Webpack, what Rollup did to make sure it was all compatible. And doing it without breaking changes was a lie. We had to release like 2 days, 8 different patches to fix issues introduced by this migration. It works now. It's a dual package now. We fixed all the issues. And like you can see that the very like narrow cases, like for example, this last release was fixing only using require in a very specific set of Node.js version from 13.2 to 13.6. Like there were bugs with very specific, like old versions of Webpack, all of like different random stuff. The problem is that like Babel runtime was like used in your application code, so it was bundled, and so we need to make sure to not break the build process of all our users. So after migrating a single package, we realized that the risk of breaking changes was too high. So we decided to release the complete migration of our main code to next major release, which is Babel 8. We started thinking about Babel 8 like in 2018, and we keep saying that it will come the year after. So next year we'll have Babel 8, and will be shipped as native ESM. So we don't have those packages, but we really wanted to like write ESM because it's like it's a new thing. Well, it was the new thing 7 years ago. It's a new thing now. We didn't want to be stuck with CommonJS. So we implemented what I call dual development. It only affects the the Babel maintainers. It allows us to choose whether we want to run our code as CommonJS or ESM by just making it like a build step completion detail. We have like this make use CJS, make use ESM command that we run after cloning our repository, and you can like choose what module system you want to use under the hood. It doesn't really matter. We can choose. It doesn't really matter. And we test both ESM and ESM compiled to CommonJS on CI, so that we know that we're always ready to publish an ESM release. We just need to like flip a flag and tell Babel, okay, now stop compiling. Like we know that it works because we test it regularly, like in every single change. And we even tried, well, I tried like 1 week ago because I realized that I couldn't give this talk without even actually trying if it was working for real. So we tried, and it works. It's still like it's marked as like -esm.4, it was just a test release. The main code will be published in Babel 8. But like this was satisfying. It took us 2 years to go there, and we are finally at the final point. And that's the end. There is one more thing after the end, which is that like people are not excited about Babel anymore. Like I know I'm not excited about Babel anymore as I was 5 years ago. Like we have all the new build tools now, like the Rust-based ones and all the alternative compilers. Except that Babel is very used still now. Like we reached 50 million downloads per week, just like 3 weeks ago maybe. And Babel is like entirely funded by donations. Like there is no, like it's not a company product. So if you rely on Babel at work, talk with your company, please. If you make money thanks to Babel, like try getting your company to sponsor us. We have this open collective page where we receive donations, and we now have 3 paid team maintainers, 3 paid team members. And like those are our faces almost. Also, like I was much younger in this picture, but that's all for real now.
Thank you so much. I really enjoyed that without breaking changes, being very confident. I've done that before as well. It never works out that way. Are there any questions in the audience? No? Oh.
After all of this, would you do it again?
Oh yes, it was fun.
Yeah, was it worth it?
Was a fun ride.
Was it worth it? Has it been worth it?
I learned a lot of things. So yes. Also, at the same time, when we started this migration, we're still migrating from Flow to TypeScript. So we had these 2 parallel things going on at the same time. It was challenging.
Would you have done anything differently if you would, like with the knowledge you have now?
Maybe I will be less confident about myself, about like.
Any other questions? See anything? All right. Thank you, Nicolo.
Thank you all for listening.